Welcome back, everyone. On today's lesson, actually, we will focus on solving one of the exercise. The exercise that I plan to solve today is actually the CATS API. So in this exercise, if you have read already the description, so we can actually look at together. It starts from here and then up to here. So it's a short exercise. So what are we going to do? First, we fetch this API. Actually, it has about 67 cats breed. If you see, if I just collapse it here, you can see 67 cats breed of different properties. And we are going to fetch this API today with Python. So yeah, so to do so, I can use Visual Studio Code or Anaconda. I have Anaconda already. So let me just open Anaconda. In the meantime, we can also read the description requirements, API data extraction, fetch, read data programmatically. So we fetch first the API, then we transform the API to this CSV format. So these are actually the columns: ID, name, origin, description, temperament, lifespan, weight, and image URL. And then after that, uh, combine temperament as a comma separated string. Sometimes, as you can see, it has some comma, so we have to put it in a string. Weight, so convert weight from imperial to metric, but we have for the weight, maybe I can show you, we have two, imperial and metric. For this exercise, we focus on the metric unit. And then also, instead of putting it like this, we will calculate the average. This is the minimum and this is the maximum. So the average is actually between the minimum and the maximum. So 3 plus 7 divided by 2, and I think it will be 5. Okay, then what else? Handling missing fields, example, description to none if empty, ensure numeric columns. Yeah, that's what I was talking about. Yeah, I think if you don't understand this exercise, just read it a couple of times until it gets very clear. So as you can see now, Anaconda has opened, and then I just use Jupyter Notebook from Anaconda, and let's see what we can do together with the Jupyter Notebook. I just love Jupyter Notebook, and it's really a great tool for data analysis and machine learning and anything related to data. I don't see anything so far, but when it's up, yeah. Yes, when it gets opened, actually it opens a server, something like this, and then I have to go to the specific folder. So our folder exists in courses, inside courses here, data analysis. So I can create maybe some file here in week 5. For instance, a new Python file. Actually, this is not, as you can see, yeah. If it's your first time using Jupyter Notebook, then you can just write here on the cell. For instance, I can say import NumPy as NP. So I'm importing the NumPy, and then again import Pandas as PD, and maybe I can import also. Maybe I can say from Matplotlib matplotlib.py plot as PLT, and then maybe also import Seaborn as SNS. I think let's see. Maybe this one is import. And then also, since I'm going to fetch data, I want to import also requests. It's a package that allows us to send requests to server. As you can see, everything is going well. Sometimes also I want to prettify my printing, so I want it to be more prettified. So from pretty print import pretty print, and what's from pretty print import word line number 6. Should I import? What's the problem here? I don't see it. From pretty. Oh no, not actually. It's supposed to be from pprint import pprint. Yeah, I had a typo there. Seaborn also, there is a typo over there. Yes. Now it seems good. Now we are about to fetch this API, as I told you. And let's see. Of course, we have to declare this URL, and then we have to put it as in a string. This one also, it would be nice if we actually add some kind of comment importing necessary packages. And then here we can also leave some comment. I think it would be good if we say fetching API data here. Yeah, then so how can we fetch? Actually, we can send request. The request goes like this. Requests dot get. Now, because we're about to send a get request, this means actually it's almost like clicking some link. We're actually trying to get resource from the server. So now let's just take the we can call this one response. The after request, we get response, and then we just stored it as a response. Then print response dot status. Status, I think code, something like this. If this status code is 200, that means actually a success. Name response is not defined. I think I made a typo. Response. Yeah, as you can see, it's 200. That means actually it's success. It's a success. That means we managed to fetch the data, but the data exists in different form now. Maybe if you don't know what this response holds, you can say print, then there, and then response, and then you will see all the available methods there. For instance, I'm interested in the JSON now because this is, as you have seen, it's already a JSON file. So we can extract the data using the JSON method there. So then I can say data is equal to response.json. And now if I just print data, it will be something. Yeah, as you can see, it looks like this. Yep, it looks like this. Yeah, but maybe now we can look through this data for card in data. And then I was a bit too quick. Print card one by one. Maybe cut name instead. And then let's see. Yeah, as you can see now, I just managed to print only the card and then maybe origin. And then you may see also card and the description. Okay, let's see. Yeah, now as you can see, the name of the cat and something, and yeah, that's very good. But instead, how about if we create a kind of a dictionary? Yeah, so a temporary dictionary maybe like this. Hey, name is going to be. Oh, what's going on here? Oh, where's this? Yeah. Then I can copy this or even cut. And then this is going to be for the origin. And then for this one, for description. And then maybe even for weight. Did I tell you that weight also? Lifespan. Has lifespan. And what's left? Maybe image. Image doesn't have for the time being. I can just say image URL and just I can put it empty. And now let's just destroy this and let's close that and then print the dictionary instead. We have some kind of a description. We made a typo, as you can see, so we have to fix that. And now we are actually printing a kind of description. But did I tell you I prefer to use pretty print, and that makes it really looks good. Yeah, as you can see, a description is this one, image URL, empty, lifespan this, and also name, origin, weight. But did I tell you that we're interested in the metric unit? So I don't want to keep everything there. I think I forgot also this. Now we have actually this one. But how do we make the average of this or this? Now maybe we can split it with this pattern at this. So maybe we can split at space, a hyphen space, and then something like that. And then if we do the same for the lifespan, then we most probably, as you can see, we got something like this. Yeah, so now what we should do, have to access this value and this value, change it to int, and then sum them up and divide it by 2 gives us the average. But are we done with all the properties? Because we are actually targeting the ID. We didn't get name, origin, description, temperament. So we have to also take care of this part. We didn't do that yet. And then cat, and then we should say temperament, and then I think we should say this p, and then what was the ID? ID is equal to also cat ID. Let's see, is it an ID here? We can just check ID. Yes, that's ID actually. So ID. Maybe I think what's the problem in here? I didn't close that. Yeah, now, yeah, I think it's almost ready, but we have to somehow do the average, but the rest is almost done. Okay, so what can we do here? And let's just do maybe a little function, something that changes this to average. So what my little function do is actually def format value, and then this should take some kind of string txt, and then it should return the average. Okay, first txt dot split at space, something like that, because I'm just taking this the operation separately. After splitting, I want to actually destructure it. See the lower part, and then the lower, and then the highest value, destructure or unpack. And then what I want to do, return int of the lower value plus int of the highest value, and then divide it by 2. That's actually what I want to do. And this function actually solve our problem. So here I have to just, instead of this, I can just pass this value, or maybe here I can say average weight. I can say format value, and then I should give this. I should give this. And then I have to say average weight. And then how about the average lifespan? Average lifespan, it's the same format. And then we have to pass actually this again, this part. All the splitting and everything happen here. So now again, average lifespan. Yeah, now we should get a kind of a numeric value. Let's see. Yep, as you can see, this number. This is now a number. Yeah, this is a number. That's very good. But what are we left? This, the image. Now let's try to get the image. How do we get the image? Actually, the image can be found from the CATS API. I just can take you to the CATS API. CATS API. If I take you to the CATS API, the image is also exist in a different route or something. Yeah, let's wait for this. As you can see, there's this image, this API endpoint. Whenever we change this value, the ID, we get a different cut. I will show you here, okay? For instance, for the Abyss, the ID is actually for the Abyssinian, the first cut, it is Abyss. Let's see, so we should get a different cut. I think I made maybe a typo or something. Then I have to check again. What is the Abyss? Okay. I thought I did it. ABY. Okay. ABYS. Ah. Ah. Maybe something has happened. Uh, oh no, actually it's not the ID. Instead of the ID, actually this one, the reference image ID. I'm sorry. The reference image ID is responsible for that. Okay, let's try with this one. Yes. Yeah, we got that one actually. Yes. And now let's try to the second cut with the reference image ID. Yes, this one. Okay. And now if we change this again with the reference image ID, and then we will get something. I think I copies not that one. Instead, it should be this value. And now let's see. It should be this value. Yeah, we got a different cut. So I understood based on this documentation, the documentation of the CATS API. Now we can implement this CAT URL. How can we implement? Then we can say, maybe how about if we try to just first get the ID? What was the name of the property? Reference image ID. We can copy. Maybe if you have a hard time to write, then you can do this. And then the best way, some cats may not have actually reference ID. So what we should do, cat.get. The get method is good because when the key doesn't exist, it gives us null. So I can say something like this. And then we can create an image URL. Image URL is equal to, I think if there is reference image ID, we can attach that. Maybe I can take this. How we can attach it is actually with like an F like this. We can attach this value where here we change it here. So I can just dynamically inject that value over here. And then as you can see, cat.jpg exists for all the different cats, but the one that's changing is the reference image ID. And then if it doesn't exist, then empty value. Now I can actually refer image URL. That's, yeah, now, oh, it seems expect else after if expression. I thought, oh, if, I'm sorry. So there should be else here. And now there should be value for the image URL. Have you seen that? If I open this or any of this link, I should get a cat. Yeah, of course, this looks like almost the dog, so don't be confused. Maybe we can cut a different image and then that, okay, that's still a cat anyway, but because we're dealing with different breeds of cats, so you may get cats that doesn't look like a cat anyway. Yeah, I think we are almost done. But how about if we create another list of cats? Maybe we can call them cats, something like this, and then populate this. So we can say cats dot append the dict. So this dict. And then if I say print cats at the end, yeah, we get something like that. If you want to prettify it, it looks like this. Now it's all about actually changing this to a different what is this, a different form of data. So we want to transform this to CSV. So how can we transform this CSV? I think at the very beginning, if we use this as in a different, I want to keep this one as it is, because this is the best practice way of doing Python. But what if we used uppercase for the keys like this based on this? So how about if we start like that? Then maybe let's start like that. But before that, maybe I just want to show you, hey, panda dot data frame, and then if we pass the cards, what do we get? Now, as you can see, we just get something like this. We got, yeah, something like this. But the problem here, the columns are not uppercase based on the requirement. If that's the case, then we can actually use, we can change the columns at a different approach. So I should say ID, I think, is it like that? I have to check. ID, name of, yeah. So ID, and then name, and then O is uppercase again. O, and then description, and then lifespan separate. I don't know if those are also uppercase. Lifespan, yes, actually lifespan, something like this. I think I just want to take, instead of coming and checking every now and then, I can just keep it here for some time. As you can see, lifespan should be something like this. And so I don't need this anymore. And let's check out this one, wait, and let's check this. And then URL. This one. Yeah, now let's try this. Now, as you can see, it's a bit different now. Now let's create our PD. PD means data, DF, data frame, and then PD, pandas, data frame. From our data frame, we can actually create, the data frame itself. So by passing the cats, let's see, df.height, and now you may see something like this. But before this, I think, okay, so now we can also just change it to before that right away. We can actually create it, what CSV df dot to CSV. And then what's the name? Cuts dot CSV. That's the file we want to create. Let's see. And now I think I should get my CSV file in the folder. Maybe I can open it because I have this project somewhere. Courses, and then let's see here. I think we are working over here. Maybe I think it's in a different, where are we? I think it should be somewhere. Where is it? I don't see it at least. Well, let's also, yeah, at least it's here. Why we don't see it? Yeah, maybe, did I open a different? Maybe let's just open the orders. Yeah, let's open it. And then let's check now. Yeah, it's here actually, cats.csv. Now, as you can see, ID, name. Yeah, but I think index, we don't need the index. The index should be false because as you can see, there is here 0, 1 something. So we have to remove that. Okay, then we have to say index false. Maybe it has been already open. I created a new one. Yeah, now as you can see, it's really good one. So we can actually fetch this. Now let's do more of data exploration from our CSV. So how can, maybe it would be nice instead of here, let's say parts data frame, and then from cuts data frame, we're actually creating the CSV. Yeah, the name doesn't really matter, just to avoid confusion. I am just giving it a different name. So now df is equal to pd.read CSV. I'm about to read the, where is it? As you can see, cuts this one. And now I can now explore on this data. Maybe I think I can make it bigger, one level. Okay, df.head, just to see the first 5 rows. Yeah, as you can see, ID, name, origin, description, weight, lifespan, temperament, and image URL. That's very good. And then if you want to see the last 5 rows, df.tell, and then you can see, yeah, the last. Of course, you can just say df and display, I mean, the entire. I mean, it doesn't display the entire, but most of the thing. And then as you can see, it has 67 rows, but 8 columns. These are the columns. How do we get the columns actually? df dot columns. Yeah, you can get this. This is not it's not a list. It's a kind of an NumPy array or a series. If you want, you can change it to actually to a proper list. Then you can just change it to like this, and then columns, and then this a proper list actually. How about then let's see the shape. Now you can say just df and then shape to see how many rows and columns. 67 rows and 8 columns. As you remember, maybe we have actually 67 breeds of cats. I mean the rows, all the rows. This one, this one, this one, up to the 67. And now let's move on also. Maybe slicing out each column df, and then if I say ID, I can just get their ID. Yeah, but that's not very important one. Name, I can get their name. And then if I want to get more name and their origin, for instance, df, hey, name, and then origin. Sorry, origin. Maybe I think we have too much of this. We need one. As you can see now, we just have name, origin, and then even if you want it to be more, weight, and then lifespan. Weight has also too much of the information. If you remember, like this, it's not just, it made it actually a bit cumbersome because, but sometimes data, real life data is, it's like that. So we can remove and just make it weight or lifespan. Yeah, as you can see, we created a new data frame again. We can also change this to CSV if we want, if we're interested in name, origin, weight, and lifespan. And then if you just say this, dot to CSV, dot to CSV. Oh, how is that? Let's see here. Here's CSV, yes, to CSV. And then simplified, cuts, read, to CSV. And then if we go again, we may see a simplified version of this, yeah? But as you can see, still there's an index. We have to remove that index. Index is not important here. So what we should say, hey, index should be 0. No, false. False, yeah? And then by the way, okay. Now we can check it again. Yeah, as you can see, it's already modified. That's very good. Yeah, now let's get more information. So we load already, so there are still some properties. Then how about if you say dev.info, and yeah, this gives you information about the data. And as you can see, we have 67 rows. None now means there is no null value. So the ID, all IDs have actually values, name, and then, but I can see here the image actually, the image URLs are actually 67. That means two of the values are missed or no values. Yeah, so we will figure out which cat breeds do not have image URL at some point. Yeah, and we can also use df.describe, and then this allow us to get descriptive statistics of this. As you can see, total count is 67, the mean is 13.74, the standard deviation 1.5. Why? I think there should be also it shouldn't be only lifespan. How about the weight? Oh. When we do calculation, the weight was not good, guys. So we have to actually fix this problem. No, I didn't notice this. So I think our calculation has problem when it comes to the weight. So let's go up and fix everything. So what was the problem? Let's see. Metric. Yes, this should give us a proper. Maybe let me just print the first 2 or 3 cuts, and then that will be easy for me. What it's something like this. So what is the problem here? Wait, lowest, I think even lower instead, actually lowest would be a very good. Lowest, int of lowest plus int of highest, yes, divided by 2, and this should be okay. Oh, this comma, as you can see, unnecessary comma over here is actually causing a problem. I think by doing so, everything will be fixed from top to bottom. So we have to run it again, but it seems we didn't fix it yet. Not yet. Because we have different code in different places here also. I have to fix it. Well, yeah, I have to. Instead of actually now, as you can see, I'm using this function in different places. How about if I make it global, this function at some point, and then I can just use it in one place, and then I don't have to create multiple function, yeah? And then when I'm just make a fix, I fix it in one place and it will work everywhere, right? As you can see now, the weight is actually proper weight. Yeah, now we got actually the descriptive statistics value for weight and lifespan. These are the numeric values in our data set. Okay, so as you can see, both the lifespan and the weight, they do have equal number of observations or records. As you can see, 67, 67. The mean weight is 4.7. The mean lifespan is 13.74. So as you can see, the average lifespan of a cat is almost 14 years. And then the average weight of a cat is almost 5 kilogram. And then the standard deviation here, it's not very bad, but even the lifespan is much better, the standard deviation, because there's no much variance. So that means the distribution is actually like kind of uniform. So mean value 3 and this one 10. So as you can see, the mean is 14 and the minimum value is 10 and the maximum value is 19. Okay, so a cat can live up to 19 years based on this data. Okay, that's very good. Sometimes we can also do some kind of a descriptive analysis for include all, give us actually like descriptive analytics for values that are not quantitative. As you can see, for instance here, top. So as you can see, this one is yeah, top means it's based on alphabet. This become the top alphabetically. This both the ID and the name and origin, United States became actually the most frequent countries that do have many cats. Frequency, of course, Abyssinian ones, yes, but this one, the United States, 28 times. So it gives us some kind of descriptive analytics for qualitative data also. Yeah, let's move on, but it's just to see the big picture, not like a more detailed approach. Okay. What about if we want to, I mean, get only the some part? I think we did already that part and we store it, but how about if we create some kind of visualization also? What does it look like? Df and then maybe a group by origin. And let's see what does it looks like. Group by origin and sort. values. Hmm. Oh, no, count values. Yeah, count, but as you can see, not a very good approach. As you can see, we have all the count give us. It count everything, but not in a very systematic way. So what we should do first, let's focus on again on the origin, okay? After we group by, and then we just target origin. Okay, something like this. Now we got something like this. This is really good. But after this, how about if we sort it like this? Sort, not sort values. Yeah, sort values helped me to be sorted. As you can see, ascendingly, then we can actually change this so the order. So, but I think I prefer it to be ascending by default. And now, if I want the countries, I can say uh, countries. So this one is actually the index. The origin is the index. So countries is equal to, but we have to first, I can call this origin, sorted origin. And then from sorted origin, we have countries, sorted origin dot index. And then if I print this, print countries, you will see, yeah, we get this. How about the values? And then the values, sorted origin dot values. And then if you want to see the values, you see something like this. So 28 times the United States. Now we can make actually a Matplotlib visualization. We can say, hey, plot, and then I think bar graph, and then on the bar graph, I can use what is the first one is actually the countries, the label trees, and then the next one is the values, and then this should give us actually some kind of bar graph, something like this. But we have to make we have to fix the label. Okay, now we don't have to print this value. We can remove that. And maybe we can add for the time being PLT dot, PLT dot X level countries and PLT dot, okay, I'm a bit too fast, PLT dot Y level. It should be parts breeds and PLT dot title parts breeds per country or something. Let's see. Yeah, as you can see, we have now label, and most of the time it's good to complete the creation of an image. The show is actually kind of completing, but this is a bit, so we have to fix that. There is this rotation. I think rotation, where do we put? Can we pass here rotation? Does it support? Maybe I think it's the more to the axis. PLT dot x ticks rotation. Maybe I can start with 90-degree, and let's see. Yeah, as you can see now, it just became very vertical, but we can also make it a bit slant. How about if we have, like, for instance, 65 something? Yeah, but no, it didn't work well, as you can see. Maybe sometimes when we have a word like United Kingdom, United States. United Kingdom can be UK, United States can be US, United Arab Emirates could be what is this? United, oh, maybe, let me just change it to 90 and I can see everything. No, that, but okay. Yes, United Arab Emirates, UAE actually. So we can change that. Yeah, I think then maybe if you want to also have this of a figure plt dot save fig, and then you can say cuts breed dot png, and then it should be actually created. An image has been created now, and then you may get somewhere here. Yeah, let's see. As you can see, still we have to work on like the dimension, because I think some of the labels has been uh, cropped or something like that. So we have to work on that. I think you can keep working on that. How about if we also apply maybe Matplotlib? Now you can go to how. I think for visualization, you can go to the Matplotlib library here, and for instance, you just check examples here. For instance, yeah, for instance, if I am interested in the uh, pie chart, now I can see some kind of donut chart, and this is a kind of a pie chart. And yeah, I can, for instance, make use of this if I want. Yeah, this is how we use. So once, if you are familiar with Python, after that, so in my case, this means actually the countries. Okay, so these are labels. It's going to be countries. So I don't need this value, okay? And then sizes means in my case, it's going to be what is the values. Okay, then even I don't have to, I can just remove it like this, and then I should get some data. Cannot multiply sequence by non-int of type float. Hmm? Okay, let's say maybe the labels would be, I think the labels should be a must there. So sorry. So now plt.show, and we have to, yeah, but as you can see, this is not, I mean, it's not the base. And then we need this auto picked 1%, 1, and then 0 f, just to display the numbers. I mean, how many? This 42% and this is 12%. So the United States cat breeds is actually 42% of the entire cat breeds. So they do have many, I mean, they do have 28 cats. But as you can see, this needs also, again, some kind of fix. So we have to make the rotate label true. Rotate labels, I think true can make it a bit like this. Yeah. So, but well, it's not the best pie chart, but at least we create a pie chart from the same bar graph. Yeah. Now, for instance, if we want to look for all the what is this df dot image URL, because I told you the image URL, it has actually some missing values. Yeah, this, so which one are they? Do we know? How do we figure out? And let's see. Yeah, this gave us actually small amount. Sometimes we can actually display most of the values of the data frame values with this like pd.set option, display maximum rows, as you can see, up to 100. So you can actually change this value. And now in our case, actually, we have 67. So we want to display all the values. Yeah, by doing so, this cat doesn't have. So let's see, which cat is it? Name. As you can see, this cat, the European Burmese, and another cat, Malian, do not have image. Yeah, but sometimes if you have really a huge data, this approach is not the best way to find the missing value. So we should follow a different approach, I would say. So it would be more of, I think, finding the missing value, and that would be, it would be something like this. df, mm, then image is null. I think with this one is null. I think it's something like this. No, now, as you can see, we figured out now this are actually there. So we call this actually, what is this? A Boolean indexing. So using Boolean indexing, we can filter out. We just filtered out. Okay, good. Maybe we can keep filtering out. Our DF is here now. Everything. Maybe because of but this is now everything is just displayed, and then it's a bit boring. I don't want to do that everywhere. Yes, maybe I just want to run from top to bottom. Sometimes whenever you want to run it from top to bottom, you can say run and run all cells, and then you get, well, good, I think. Yes. Now, so maybe how about if we are looking for cats that live more than 15 years, yeah, 15 years. Maybe I just want my cat to live longer, and so I want to do that. But we have to first copy this. How do we do that? df. Maybe I can show you first. Let's just filter out all cats from America, okay? All the cats from America. And then by doing that, it would be easy. I think it says United States, uppercase, States. And then, as you can see, these are all the cats from the United States. Not those, this one. Oh, no. I think we made some kind of mistake here. What's the problem? No, this should be origin, guys. Origin. Yeah, now if I see, let's see, yeah, as you can see, United States, United States, United States. Maybe let's even look for from United States and lifespan, df, lifespan, lifespan greater than 50. What? Oh, I have yeah, because this when we do this kind of comparison, it actually requires some kind of parentheses. Otherwise, this panda get just confused, So how about if we do this? Yeah, as you can see, we got actually 4 cats that lives more than 15 years and origin from the United States. Yeah, so you can make some kind of conjugation actually. Yeah. Um, yeah, you can add even their weight also. Yeah, if you prefer lighter, maybe some a cut that is lower than 5, and then you will get this one. Yeah, I think it's possible to do a more filtering. We call this filtering using Boolean indexing. But I'm just now interested if there's some correlation between the weight and the weight. What is this? I think we need one more of this, and then the lifespan. There's yeah, but I just extracted only this. Then how about if I say correlation? What's the problem here? Not in the index. Yeah, here is not. It's wrong. Okay, it's wrong. Okay, let's say lifespan and weight, they do have about 0.25. Weight and lifespan is it's like it's the same. This is very small. I don't think they do have kind of a correlation. Maybe if we also made a kind of a scatter plot, let's see, weight is equal to df weight and then what was lifespan? df life it's per case lifespan, and we can make actually a scatter plot and see how it looks like. Scatter plot, the weight versus lifespan. Let's see. Reality.show. Yep, as you can see, it doesn't have any pattern, it doesn't have any relationship. I don't see any kind of relationship. The data is just everywhere. So I think we can say it doesn't have any relationship between the cat's weight and the life span. So I think the point of this exercise was actually to learn how to fetch API and then to transform the data to CSV, and then after that to fetch the data on Pandas and change it to data frame, and then manipulating the data frame and doing data exploration and some kind of visualization. I hope you get this insightful, and in the second lesson we will work on another data set. Maybe let's just check if we missed anything that we didn't cover. I think this is good enough for today, so we can end our exercise session here.